Hi, this is Anthony from Black Sheep, and we'll show you how to run the file. We made a few changes since the demo to make the gameplay a little bit better and make it a little more true to the beat mapping. You'll notice if you go into the main C++ file, this one, down towards the bottom, you'll find a you'll find a place where there's the wave file is loaded in. It's two little strings, same wave file. You can load in any 16-bit wave file, but we like this resistance.wave. It tends to give pretty good results, and we'll include that in our upload. So also, I'll show you the music event C++ file. This is where all the beat mapping and parsing goes on, and a lot of stuff there, but I'll put a breakpoint right here. That way you can see the product of it. So let's compile. This will take a minute. Alright, so done compiling, and we ran it, just finished its pre-processing. And here's our vector of node events that it returns, music events. So you can scroll through that a little. There's 1,541 of them for this particular song. And you'll notice there's a beat occurred boolean on it. That tells you whether it was a downbeat or whether it just turned out to be one of the random rhythm events. And here you can see the data that's actually inside of it. There's a true few booleans for our parsing. There's the beat, there's the actual BPMs in there, and a few other metrics like the current amount of audio magnitude, and there's a what time it occurred at, both in samples and in seconds. For example, this particular one I think occurred at 30 seconds in. It's off screen, so it might be difficult to see. But you can go ahead and put a breakpoint in here when you run it too. You can check it out. There's a lot of different stuff in there, but I mean, that's still just data technically. So better see it in here, then it would be better to see it in here where you can actually kind of see the actual mapping out. We improved a little bit of it here. Notice we have a lot more stuff generating. Enemies are probably the best way to see the beat relation. Once it gets into a little more of an intense spot, you'll notice more stuff spawning, but they tend to spawn right on beats pretty consistently. And if you notice, our BPMs are staying at a pretty good constant. The song's probably 135 to 140 kind of range. Oh, there we go. Seeing a few more enemies spawning and stuff. Alright, so I let it skip ahead a bit. This is a part of the song that's a little more intense, or at least it's coming up to the part. And you'll start to see, oh, there's our fish coming in, spawning on time. A few question mark boxes coming in on time, and then there's our fish again, spawning on time. And then we'll see some turtle shells and stuff coming in soon too. Those are coming in on beat as well. And the flashing in the background is actually on each percussion event as well. So, you know, we got the enemies coming in on downbeat, and then the other elements coming in, like the background flicker comes in on the smaller percussion events. So just overall, you can see our music parsing is actually parsing out the beat of the music, and it's generating a pretty big array of events. It's able to tell the smaller percussion events from the from the from the downbeats and such, and then on top of it, our game engine is mapping them to elements that would be there to help create some good gameplay. So overall, I'd say it's definitely a pretty good start in getting a music-based game that really gives you the feel of the music. So this is definitely some code that we're going to want to keep around. We'll probably go back, tweak some stuff, probably reuse this to make some good music-based games. It could probably be good on a platform like the iPad or something like that. You know, just a fun kind of music-style game. But yeah, this was definitely worthwhile to us, both for the content of the class, but you know, really helpful as programmers and designers. So thanks. It was a really good semester, and we definitely got a lot out of it. Thanks.